Hello. We are going to go over right now the review sheet for our test on Friday. Now, I'm not going to do a lot of the stuff on the calculator. I am going to assume that you are able to do this. First thing, make sure that when you type in your first list, you have cleared your lists first so that your data is accurate. When you do this, there can be only one right answer. So the right answer for this first problem would have a mean of 88. Your standard deviation to the nearest hundredth should have been 8.20. Variance, if you recall, comes from squaring the standard deviation, and in our notes we define standard deviation as the square root of the variance. So if I square 8.2 and round to the nearest integer, I get 67. And now I want to know about how many scores are one standard deviation of the mean. Well, that's going to come from my normal curve. So I put my mean of 88 here. And if I add 8.2, I have 96.2 here. If I subtract 8.2, I have 79.8 here. Now that will tell me on my chart that I need to be looking at this set of values. And if I add up all those numbers, I come up with 25 scores are one standard deviation from the mean. Now, the next question is saying what percent of the scores fall within one standard deviation of the mean? And what they're asking is what percent of the scores on the data that we gave you, not from the curve. Because they gave me the individual pieces of data, not just a mean and a standard deviation. So since I have the data in front of me, there would be 25 out of the 35 scores given, which would give me a percentage of 71.43. Then, is 99 an outlier? If you recall, an outlier is a piece of information that is really far away from all the others, and it kind of throws your data off. So 99, no, is not an outlier, because 99 is very close to the prior interval. Now, if it was really far away, it would have been an outlier. Second question, I have to use my curve again from the front page. I'm going to have to draw my own curve. I have a mean of 71. So again, my mean is dead center, here 71. Now, it's asking me about the scores between 71 and 77 when my standard deviation is 4. So if I go out one z-score, that brings me to 75. Two z-scores bring me out to 79, but I wanted to stop at 77. So that means I need to be at the halfway mark. There's my 77. So if I add up the percents, there's the 19.1%, the 15%, and then the 9.2%. Adding these percentages up, I find that 43.3% of the 15,000 students fell within this range. Multiply that out on my calculator, 0.433 times 15,000, and I come up with 6,495 students. Next question, on a standardized test score, 86.6% of the students lie between 64 and 85. Well, I don't know my mean, and I don't know what's at the mean plus a standard deviation, but if I'm going to go to 85 and I'm going to go down to 64, I find that to get to 86.6% of the data, I need the 34.1% here, the 34.1% here, then I need this 9.2 and this 9.2. These will now all add up to 86. So what that's telling me is that from the mean, I went 1.5 deviations this way, and I went 1.5 deviations this way. So this distance is 3 standard deviations. Well, 85 minus 64 equals 21. 21 divided by 3 tells me that each standard deviation is 7. So there's my standard deviation. Now number 4, I needed to put this into my calculator. So again, I'm not going to do the calculator for you. You need to hit second memory 4, clear out everything from list 1, and now you have to put this in on list 1 and list 2. So if you need to, pause the tape and get that in. Now that you have that in, if you have a newer version of the calculator, when you hit stat, and then you go to calculate, and then you cursor down to power regression, make sure that you take the frequency off list 2. The newer calculators only. The older calculators, you don't have to worry about that. And make sure that you write your regression equation accurately. So your regression equation was 2.001 times x raised up to the 2.298 power. Once you write your equation, then and only then will you, on your calculator, plug in and find the answer to the second part. And the answer to the second part would be your 2.001, 15 minutes goes in for x, raised up to the 2.298, and rounding this answer to the nearest integer, as they said, you would have 1009. Number 5, again, clear your lists. Take your time, enter your data as accurately as you can, and this time when you hit stat and calculate, you're going to cursor down to the linear regression because that's what they're asking us for. And we get y is equal to negative 0.112x plus 23.448. When they want a water depth of 255 meters, 255 again is going in for x. So if you have y is equal to negative 0.112 times 255 plus 23.448, this becomes negative 5 degrees Celsius. Final question on this page now is going to sequences. So this is recursive because they're telling you you have to start at 7. So there's my first one at 7. Now if I want my second one, I have to take the first one of 7 minus 2 times n, which is 2, and 7 minus 4 will give me 3. If I want the third term, I now take the 3 minus 2 times 3. And this is going to give me negative 3. The fourth term, I'm going to take that negative 3 and subtract 2 times 4. And that's going to give me negative 11. So recursive sequence. Number 7 is also a recursive sequence. Number 7, again, my first term is negative 3. So my second term is going to come from, my second term is going to come from 2, because they're telling me here to use 2, times the one prior, and then add 10 to that. That's going to give me 4. My third term is going to come from 2 times the 4 plus 10, which is going to make 18. And finally, my last term is going to come from 2 times 18 plus 10, which is going to make 46. And the next few problems from 8 to 13 will be on the next video. Hopefully you found this helpful.